Dear students, I am back again. So we will probably start with the part 2 of this. So we already learned the part 1 where you will see all these things. So if you have not gone through the part 1 of set 3, please see. Otherwise it will be a little difficult for you to understand. So what we learned what is a set and what is not a set. What is a set and what is not a set. These things we have already learned in part 1. So mainly what is not a set, we discussed that where the answer is not fixed, where the answer becomes variable. So that is not, those things are not a set. And after that, we learned the representations also. Representations mainly we did roster form, and the SB means the set builder form. We tried to write set like this. Main is it's the roster representation. We learned what is the cardinality or the cardinal number of a set. That is like this. N of A, that means the members, how many members are there, that we learned. So it's 3. Today we are going to learn, now in this video we are going to learn first of all the types of sets. And we are also trying to cover up the intervals. Okay. So these are the two things we wish to cover in this particular video. Now set, as you have already learned that set may be, if you just discuss it, which is a set and which is not a set. So I am ignoring this for the time being. Then not a set, we will discuss that. We want to categorize this set. So this set has got main 2 categories. One is the finite set and one is the infinite set. Now what is a finite set? Finite set means where the number of elements are countable. That means you can count really the number of elements. Say this set ABC will be a finite set. And infinite set means where the number of elements are or cannot be counted or are not countable. Now I want you to understand that there is a very fine difference. There is a very fine difference between this infinite set and not a set. Okay, there is a very fine difference between this infinite set and not a set. That means if the elements cannot be counted, okay, please stop thinking that it is not a set. It might happen that it is a set and the number of elements are infinite. That's many elements are there. For example, say real numbers, capital R. Capital R is what? It's a set of real numbers. So obviously many real numbers are there. Say I can write minus 4.5 or 5.1 or say 6.009 or 1, 2 or say root 2, root 3, anything over here. So obviously the number of elements we can write over here are uncountable. So that is a kind of infinite set. Now what is the difference between infinite set and not a set? This is very important. See, infinite set means you know what to put. You know what to put, simply you cannot count. Say n. Do you know what is n? You know, all of you know. Most of you know that n is natural number. N is natural number. So you know What to put inside it? It's 1, 2, 3, 4, 5. Do you think any fraction to be put over here? The answer is no. We don't include any fraction over the natural number set. So look at it. So many natural numbers. So automatically this is also an infinite set, but elements are not counted. That's why infinite set. Now the thing which we discussed, that not a set, sometimes we say that the stars of the universe. So the universe is not properly defined. So we cannot say like that. So that will not be a set. So we have to understand what is infinite and what is not a set. Now very interesting question, if I ask you that all the animals living in the world, is it a set? Yes or no? All the animals or all the living organisms, so is it a set or not? So this is the question. Now think that all the organisms, it's obviously it's kind of a huge, but still you can count if you take the pain of counting it, because every time every second or every nanosecond some more organisms are added, they are born, and many organisms die out also. But if you lock all of them, if you lock of them under a specific time frame, it's still countable. Okay. Say, so this is a set. Another funny question also you can understand. All the hairs on your head. All the hairs on your head. All the hairs on your head. Is it a set or not? Yes. This is a set and this is a finite set. Okay. This is not something infinite, because still, see, all the hairs on your head, you can still count them. It is a very difficult task, but still you can count them. So these things are, this is also all the living organisms, this is also finite set. It's not an infinite set. So again we can discuss all the water molecules. On earth. All the water molecules on earth. Is this a set? Yes. This is also a set. How we can calculate it? We can calculate, of course, with some approximation, that we have to calculate how much volume of water exists in the ocean. There is some kind of approximation to that also, and we can also calculate that how many molecules exist in the unit volumes, and you can multiply with that to get the approximate number of total molecules of water on the earth. So that means this is a set. These are kind of a little tricky questions, but all of them are set. None of them are kind of infinite set. Now these are all finite set. Now infinite set, I told you, real numbers, natural numbers, you can also say all the integers. So integers also include the positive integers, the negative integers, you can say all the whole numbers. Those are kind of infinite set. Okay. Now we will try to categorize this finite set. Finite set, the first I'll try to write a singleton set over here. Singleton set means, say, a set containing a single element. A set containing a single element is called a singleton set. That means you get the cardinality of A as 1. So that means single element, only one element is there, and that is a singleton set. The next, what we will try to find out is a void set. So that is a void set, or say an empty set, we will try to find out. So we write here empty set or void or null, NULL. So here the set has no elements. The empty set or the void set or the null set, they have got no elements at all. So we often denote this empty set as, this is a symbol, it's actually OE, it's a German symbol, but you can still call them as phi. Okay, no harm. Nowadays everyone in all the book it's written as phi, so you can denote it as phi. The phi means it's an empty set. Now obviously there is very fine difference between a singleton set and empty set. Now if I give you an example that B is a set X, X is an integer and X lies between 1 and 2. X lies between 1 and 2. Okay. So in between 1 and 2 there is no integer. So obviously in the second line when you write, you cannot write any elements over here, and that means B becomes an empty set or a null set. So this is main difference between the singleton set or empty set. Now we will try to see two different sets equal set. This is also a type of set, equal set. Equal set means, say A has got three elements, say 3, 5, 7, and somehow set C has also got same elements, maybe in different order or same order. We call that A is equal to C. This is equal set. We call that A is equal to C. So what is equal sets? What are equal sets? So when the elements contained in a particular set exactly match with the elements of another set, or you can say that the elements are same. Elements are same, we call them as equal set. The next category is very interesting. We write them as equivalent set. We write them as equivalent set. Now if I discuss another set, say D, with X, Y and Z, X, Y, 7, 3 elements. Do you think that A is equal to D? Do you think A is equal to D? They are equal sets? The answer will be no, because the elements are not the same. But these two sets, A and D, are considered as equivalent sets. A and D are considered as equivalent sets. Why? Because when the cardinality of two sets match, in fact C also, when the cardinality, or you can say that C is also equivalent to D, when the cardinality of two sets match, we call that those are kind of equivalent sets. I'll try to cover intervals in the next part. Thank you.